Hello grade 10s, welcome to my channel. Let us have a look at this question paper so that we can assist you to prepare for your paper 2 examinations that are upcoming. We are going to take our paper from November 2023 from Gauteng. This was a 2-hour paper for 100 marks. Of course, instructions, folks, need to be read with understanding. For each paper, one sits for, right? And the rounding off here is only 2 decimal places, no more than 2, no less than 2, okay? A highlight also is that diagrams are not necessarily drawn to scale, but they still have to send the correct message, failing which the whole process is a scam. Okay, so of course, guys, there is statistics which we're not going to look at in this review because it's not relevant for the upcoming test. So we'll start with analytical geometry, which is part and parcel of the upcoming exams. So we read what is given. So in the diagram below, what is going on? Why is this not doing the things now? Here one. Hey. I don't know why now it's not doing. Hey, can't what is wrong with this pen? It no longer works now. Sure. Hey, into this long anyway, doesn't want to point. I don't know why. Anyway, in the diagram below, point P with coordinates 2 and 9 is a point in the first quadrant. Good. A. So A is not stated. What is cooking with it? So we can only think about how to think about it or how to approach it. R with coordinates n and minus 13. So that's a potential question. So we need to also consider how to arrive at finding n, which is a point in the third quadrant according to the diagram, as well as A. So we expect n to be a negative number, right? And M are vertices of a parallelogram. So M is also X and Y, right? But we see that point M is in the first quadrant, so both X and Y should be positive. Now this is good. These are vertices of a parallelogram, PAM, right? And we can see it nicely. And also we can add opposite sides are parallel and equal. Okay, we can indicate that for the parallelogram. PMT is a straight line such that M is the midpoint of PT. Okay, that's good, already indicated. Point T is 10 and minus 3, which is a point in the fourth quadrant. The X is positive, the Y is negative. That's good. Right, and it is a point such that PT is perpendicular to RT, and that is also indicated. Sometimes when it is not, please annotate. All right. So now let's sit back. What can we do with this? Well, M is easy. We can use the midpoint formula there to get things done. So it's 10 plus 2, which is 12 divided by 2. That's 6. This is going to be minus 3 plus 9. That's 6 divided by 2. That's 3. So we can find the coordinates of M easily. So what else can we do? Well, with PT, we can find the equation, or PM. We can also find the angle of inclination. Also from the equation, we can determine the x-intercept. So that's what we can do. But now what about Rn? Unfortunately, we do not know that distance MR. So we cannot use the distance formula there. But since we can find the gradient of PT, we can also say the gradient of RT multiplied by the gradient of PT should be -1 because of this perpendicular relationship. As a result, we will only have one unknown in that equation, so we can solve for Rn using that. And once we have the full coordinates of Rn, what can we do? Well, we can use symmetry to get the coordinates of A, because we can just look at point M and see how we took it back to point P, right? So we took it back how many units? From 6 to 2, we actually took 4 units, so we subtracted 4 units. I'm just going to put a -4 just to show the action, or we can just say 4 units back, still okay. Now, the same way we're going to take R back to A. Symmetry will always work in our favor in this regard. Okay, so we're going to take this back some 4 units as we will have done there. But now we say we took this one up how many units? From 3 to 9, that was 6 units up. So the same, we're going to take that point R 6 units up and 4 units to the left to get to A. So please guys, know these things, they are not so easy to see sometimes. This is why it helps to sit back, think about the approach, plan, and even recognize if there's anything missing. Then you can see that, okay, I am not able to solve for this, then let's take it back. What can we do? We read and scheme and scan these questions to see if at all this is a question for us to solve. If it is, we will see what extra information is given and quickly analyze how we are going to use it so that we can choose our battles well. Remember, in the exam, you only answer questions you can handle. Leave the ones you cannot for later, if at all later will exist. All right. So now we can see that in our diagram, we are pretty much able to work everything that is in front of us, also using symmetry in a way. So we can handle most of the business, so there's no need to scheme and scan the questions. So we'll start with question 3. Question 3 asks us to determine the length of PT and to leave the answer in set form. Easy. So we've got 3.1 with 3.1.1. We are going to use the distance formula here. So this is x at t minus x at p all squared into y at t minus y at p. This is going to be equal to the square root of x at t, that's 10, minus that at p, that's 2, all squared, plus y at t is minus 3, minus 9, all squared. At this point, to simplify is a pointless exercise. Just put it in the calculator, make sure everything is as it should be. So the key to this calculation is just basically correct substitutions. If they are bad, then the answer is going to be bad. Now this one gives us 4 root 13 units. We need to state this is units. How do we score these 2 marks? Substitutions and the answer, provided, guys, we can see the formula. If we don't see the formula, those substitutions don't make sense. Yes, we understand because we know the subject, but for the student presenting answers in the exam, we are the ones who pretend we don't know anything. So you have to make sure you convince us, and rightly so. Okay, listen to me. Considering myself an examiner, and I am not even a teacher. Okay, doesn't matter what I am. What matters is that I'm helping you. If at all, this will help. Now, 3.1.2, we need the gradient of PT. Again, we can handle this. Gradient of PT is going to be y at t minus y at p divided by x at t minus x at p. Now y at t, this is minus 3 minus 9 divided by 10 minus 2. So this is minus 12 over 8, which is going to be minus 3 over 2. Great. So I can just put it in the calculator or evaluate it. Sometimes don't starve your brain a chance to stay awake. So simple calculations, please use your head as best as you can. Again, the anchor to this is substitutions and the answer. Otherwise, there's no checking if this is true. But again, if we look at this, this is 1,5. That's a fairly steep gradient in the negative, direction, so to speak. So it's a decreasing gradient. So we can appreciate it. Although this is not exactly drawn to scale, but proportionality, or should we say proportionally, we can appreciate this should make sense for that answer. Okay, 3.1.3. We need to find the gradient of AR. So this is good. So we know that the gradient of AR should be equal to the gradient of PT. Why? Okay, which is equal to minus 3 over 2. Why is that? We know that it is given that AR is parallel to PT. Right? The annotations told us so. So we know parallel lines have equal gradients. I think the mark is more on the reason here, because the value itself is literally, already marked above. And this is just for us to repeat it. I don't know. It depends. But remember, the etc. part of instructions on how we determine our answers needs to show up. It is often ignored, but I feel like the very examiners themselves abandon their own instructions when they do not become strict in this regard, because we cannot put instructions and then forget to enforce them. This is the law that governs how one answers this paper. So that law needs to be respected by the candidate. Okay. We need the coordinates of M. We already saw how we're going to do it, but of course we need to show how we've done it. So M is this point such that x at t plus x at p divided by 2 is to y at t plus y at p divided by 2. Okay. We will see that our M, x at t, this is 10 plus 2 divided by 2 is 2 minus 3 plus 6 divided by 2. Not plus 6, plus 9. Goodness, can you see? Silly things just come in. Therefore, M is, this is 6 is to 3. This is done. Okay, it's a point in the first quadrant. Its position is reassuring. Yes, not drawn to scale, but we can appreciate that. Again, the anchor here is substitutions. Right. 3.2. We need to determine the equation of PM in the standard linear format. Of course, not a problem. So we know that PM as a vector or a line on the Cartesian plane, not just the distance. Right, it's going to be y is equal to minus 3 over 2 x plus c. Because M and P and T are collinear points, so the gradient between any two is going to be the same. So we then substitute. Usually I prefer what was given rather than what I determined, except when I cannot avoid what I just determined. So this is 3 over 2 into 2 plus C. So Papa wena. Therefore, C is, now remember the 2 will divide to 1, so we transpose, we get 12. So we can say, therefore, Y is equal to minus 3 over 2x plus 12. Okay. Now, obviously, if this graph is at 9 at P, if we produce this line, well, we can almost picture that this is not that far from 9, so 12 is okay. So sometimes just look at it and be sure that, yes, not necessarily to scale, but we need to accept what we get. Unless, of course, really this is a bad drawing. Then a bad drawing will always give a bad result, right? And therefore you never know when you are right and wrong. Remember, the impression that we learn from anything we do here is whether we are okay or okayish, all right? So of course, writing the equation like that is good, especially knowing the gradient is going to be the same since those points are collinear. Substituting that point and the final finish. That's how we get our 3 marks. Okay, this question continues here. So we have 3.3. Oops. We then need to show that n is equal to 5. I don't think so. That's a point in the third quadrant. I will not accept that. So perhaps a negative. Maybe there's a misprint or something. Of course, this may be okay to live like that because someone may say, well, look, this is not drawn to scale. This could be a point here, but I believe it is not so true. Because if the Cartesian plane says point R is in the third quadrant, then the answer must be giving us what is in the third quadrant. So it should be negative. So there's no doubt about it, but let's see when we calculate. So we know that here we just need the gradient of RT multiplied by the gradient of PT, giving us minus 1 because of that perpendicular nature of the two lines. So we know that gradient of RT multiplied by the gradient of PT, we should get minus 1. Why? Given RT is perpendicular to PT. Right, that's why we know. So this implies gradient of RT is going to be y at t minus y at r divided by x at t minus x at r into the gradient of PT is minus 3 over 2. This must give us minus 1. Then we substitute. This is minus 3 minus minus 13 is going to be plus 13 divided by 10 minus n into minus 3 over 2 equals minus 1. We then divide by minus 1 here. This gives us 10 over 10 minus n is equal to, so the negative will go, that fraction will flip to 2 over 3. Then we cross multiply. So this would imply we want n, so this is going to be 20 minus 2n is equal to 30. We transpose the 20, so minus 2n is basically 10. Divide by 2, therefore n is going to be minus 5. Alright? It makes sense because a point in the third quadrant will have a negative x coordinate, not a positive. So perhaps there is a mistake in the printing. But this further highlights the fact that due process is never followed when these papers are compiled and prepared for distribution. So someone is just sleeping on their job. And unfortunately, we cannot help it. People in this country that get deployed or employed in certain positions don't deserve those positions. But what can we do? We can never be too right right? Yeah, otherwise it would become a difficulty to put up with as well. Calculate the area of triangle RMT. Okay, triangle RMT is our triangle over here. So we already calculated PT, and we know MT is half PT. So this is good. We don't need to calculate that length. We just do a very simple determination. But we need the base, which is going to be RT. And unfortunately, we cannot escape the coordinates of R. So, well, what we want is to say, well, area of triangle RMT. I don't know why sometimes my writing just fades. It's going to be equal to half base times perpendicular height, right? This is equal to half. The base is RT multiplied by MT. Okay, this is going to be equal to a half of, now we know that here we need the distance formula, so we can do this calculation separately, of course, but we can do it here as well. There's nothing stopping us. So it's going to be x at t minus x at r all squared plus y at t minus y at r all squared into, this is going to be half pt, because we were told m is the midpoint. Okay, so this is going to be a half of the square root of x at t, that's 10, minus 5 is going to be plus 5 squared, plus y at t is minus 3, minus 13 is going to be plus 13 all squared, into a half times pt, we found it to be 2 root 13, not 2 but 4 root 13. Okay, so we can simplify further. This is a half into, now this is going to be 15 by 2, 15 squared is 225. This becomes 10 squared, that's 100. So 225 plus 100 is 325. Okay, 325. The square root here is 25, right? Let's see, does 325 divide 25? 325 divided by 25 is 13 years. So this is going to be the 5 root 13. Okay, but of course, if you're not so sure, check on the calculator. It's not a big deal. So a half there is going to give us 2 root 13. And of course, there's 2, because this is a product, we'll divide that. And we end up with 5 times 13. That should be 75, right? 5 times 13. 5 times 13 is 65. Okay. My math is dead. 5 times 10, that's 50. 11, 55, 12, 60. Okay, yeah, 65 units squared, or square units. Remember that last part, if it is not there and it's not correct, the last mark gets lost. Okay, so this is a calculation. This is a calculation, the general substitutions and the final answer. So that should give us the last full 4 marks. And we are walking away with some 18 marks, which I think is very easy. There wasn't any difficulty here. Perhaps the problem here could easily be this question. But anyone who understands what to do, it should not be too difficult. But we can just put a star in there and say, okay, that could be a problem, especially that the sign was negated and it's not correct. All right, okay, all right. So let's move on to question 4, which is trigonometry. Right, question 4, we are told to use the calculator for 4.1 to find the values of the following, correct to 2 decimal places. Okay, now we're going to stick with the local instructions. Even if it said no decimal place or 1 decimal place or 3, we will stick with the local against the general instructions. So 4.1.1. We've got 4 sine 65 degrees. What should this be? We just put it on the calculator. So this is 4 times sine of 65. So just make sure the brackets are good, guys. So this gives us 3,6,3 to 2 decimal places. Here we don't need to write a unit at all, but we can if we want. But at this point, we just avoid unnecessary stress. 4.1.2, we've got cos squared 32 degrees minus 10 degrees divided by 22 degrees. Okay, so this is easy. We just first simplify here. We get cos squared 32 minus 10 is just 12 degrees divided by 22 degrees. So this is going to be equal to, we just punch it on the calculator, so it just goes straight to this. Then in brackets, cos 12 degrees. And we need to square that, divided by 22 degrees. What do we get? We get 2,37 as the answer. Okay, so that's nice. Answer there. That's 2 marks. I don't understand it. Where is it coming from? Whatever. Maybe that's simplification, I suppose. Doesn't really make sense to me. 1 mark or 2 marks for the answer, I guess. Anyway, let's go to 4.2. We need to calculate theta, where theta lies between 90 and 0. So meaning theta is in the first quadrant. So whatever we get, we stop at the first quadrant. So we've got 3 sine of theta divided by 2 minus 20 degrees is equal to 0,85. Okay, so we will then divide by 3 throughout. We get sine theta divided by 2 minus 20 degrees will be 0,85 divided by 3. Please don't evaluate it as yet. So what do we know? This implies that theta over 2 minus 20 degrees is going to be the arc sine of 0,85 divided by 3. Now, we don't want to rush. This also implies that theta over 2 is going to be equal to arc sine 0,85 divided by 3 plus 20 degrees. We can say therefore theta is going to be 2 into arc sine 0,85 divided by 3 plus 20 degrees. Okay, when we cross multiply the 2 there. So what is that answer? So we can say 2 into arc sine 0.85 over 3 plus 20, close bracket. So I'm getting 72.92 degrees to 2 decimal places. Now using the standard instructions, because nobody said anything here. This is an acute angle, so we stop right there. Okay, we're not going to pursue the one in the second quadrant. So how many marks here? 4. Okay, that's quite a lot now. That's quite a lot. I would say perhaps this is a mark. Multiplying by 2 is a mark. Transposing the 20 must be a mark. Then the final answer, I guess. I don't see why this is 4 marks, honestly speaking. Maybe 2 marks would have been fine. Anyway, too many areas to consider. We leave it at whatever it is. Okay, so it says now, without the use of a calculator, determine the value of. Okay, great. Can I do it here? Let's try. 4.3, we've got cos 45 degrees divided by sine 45 degrees plus 5 cosec 90 degrees times 10 squared 30 degrees. Okay, this is good. So what do we know? Cos over sine gives us cot 45 degrees plus 5 cosec is 1 over sine 90 degrees. But why do I want to do this? I don't want to change this. It's fine like this. Leave it. Cosec 90 degrees, times 10 squared 30 degrees. Now this means we need to use our special angles. Now we know that cot is defined as adjacent over opposite, but now with 45 this is just 1 plus 5 into cosec of 90 degrees is as good as sine of 90, because sine of 90 is just 1 over 1, which is 1. So cosec is also 1 over 1, so this is 1 times 10 of 30. Now 10 of 30. So if this is 30 degrees and that is 60 degrees, this is 90. Adjacent to 30 is root 3, opposite is 1, hypotenuse is 2. So 10 is opposite over adjacent, so this is 1 over square root 3 squared. Okay, vele phaphe nje ibaleke la way. So this is basically 1 plus 5 times 1 over 3. Okay, so this is equal to, now we can, okay, so do we really want to prolong the inevitable here? I don't think so. So this is just going to be 5 over 3. Okay. Now multiply 3 there, that's 3 plus 5, that's 8. So this is going to be 8 over 3. Done. very much done. Okay, so that's it. So let's put it on the calculator now to check if the answer we are getting is good. So cos 45 divided by sine 45. Then we add 5 times 1 over sine 90 degrees. That times by 3 into 10. What was this? 10 of what? 30 degrees. Now the 10 of 30 degrees needs to be squared. I missed my 3. Lord of mercy. I did not put the 3 here. Copied this expression wrongly. So this is 3 10 squared 30 degrees, okay? This is going to be 3 10 squared 30 degrees. This is 3 into 1 over square root 3. All squared, right? So this changes everything now, because this and that will take each other out. Just leaves us 1. This whole thing is 1. And then 1 times 5 is just 5. So the answer is 6. Why my 6 is not 6ing? When 6, that's not pelwagabi. Yes, my calculator confirms. Right, so we are good. So every chance we need to check the answers, guys. There's no excuses here. All right, so knowing from special angles this is the case and that is the case and that is the case. 3 marks. Final answer. So this is us taking these 11 marks easily. Easily. We move on to question 5. Question 5 says if cos beta is equal to 3, actually 5 cos beta equals minus 3, and beta is less than 360 but greater than 180, meaning if this is negative it should be in the third quadrant. So we can say here therefore cos beta is minus 3 over 5. And we know that with these kinds of questions, we will always need the Cartesian plane. This is the origin. And our terminal arm should be here for cos, because in the fourth quadrant, cos is positive. So we cannot think about it. We want where it is negative. All right, so this is the story. Right, so cos is defined as adjacent over hypotenuse. So this means this is beta. It's a reflex angle. Okay, now we work out the y value. X squared plus y squared is equal to r squared. We got this from Pythagoras, so this is minus 3 squared plus y squared into 5 squared. You know that y squared is going to be, now this is 25 minus 9, that's 16. Therefore y, we will choose the negative 1 because it's on the negative x-axis, y-axis, okay. So once this is done, we are ready to go. Question says, we need to, with the use of a diagram, calculate the value of the following. Do not calculate the value of beta. Okay, not a problem. Cos B And how many marks? 3. No ways. Just to transpose and divide. In fact, not to transpose, to just divide. No sense at all. I would believe this question was meaning to say sine beta. It cannot be cos beta. And 3 marks. No ways. That should be 1 mark. So do you see, guys, issues of this nature should not be in a paper that is provincial, man. No, man. No, this can only happen in high school because the teacher is the only one doing this and there's no one looking and checking. Anyway, now there's no longer that situation. There's what we call subject advisors. There's what we call, subject advisors, I suppose, who then liaise with the district and what province, I guess. Anyway, guys, I don't know the structure of your schooling anymore. But yeah, I don't believe this question was on cos beta. It's ridiculous for 3 marks. So let's just answer it the way we think. For now, we can think because we are practicing. So this is sine beta. I'll demonstrate why I think this is the one. So this is going to be minus 4 over 5. See, we get a mark for this. We will get a mark for that determination of y because it wasn't there. And of course, for the diagram. Okay, I guess. Or one could even consider cos beta as perhaps the way we got our answer. Right, so this 3 marks is good for that question, but not for cos beta, not at all. Anyway, 5.2, we need to evaluate 10 beta minus cot squared, or in fact it's 10 squared beta cot squared beta. And by the way, nobody said we should not use a calculator here. But anyway, with the aid of a diagram, it's almost like do it semi-manually. It's not exactly manual, but semi-manual. Anyway, so 10 beta, what is it? Opposite over adjacent. Oops, I forgot to indicate here. This is minus 4. So opposite over adjacent, this is going to be minus 4 over minus 3 all squared minus. Cot is the reverse. It's going to be minus 3 over minus 4. It's the reciprocal. So we go about it. This is 16 divided by 9 minus 9 divided by 16. Nobody said we cannot use a calculator here, so I think at this stage we just move with the things. But let's just show it in case the meaning or the intention was to say don't use a calculator. Now the LCM here is going to be 16 by 9, right? Because it's an even and an odd number, so I doubt there will be a number where they both come in except a multiple of the two. So 16 by 9 is going to be 144. Then 144 divided by 9 is 16. 16 squared. What is it going to be? 16 squared. Is it 256? Yeah, I think so. 16 squared is 256. Minus, this is going to be 9. 9 squared is 81. So 256 minus 81 is 175 divided by 144. Again, odd number divided by an even number, not something that can simplify nicely. So we stop here. It was just 2 marks, guys. So even a calculator could have been used. What matters here is substitutions and the answer. This in between was not a necessity to go about it that way, but I get the feeling that usually this question, when asked, the calculator is normally discouraged. So I don't know what was the planning here and the intention by the examiners, because we can see that, wow, there's errors in here, and what can you do? Nothing. Nothing at all. So let's get to functions. Very nice topic that grade 10s need to master, because it just keeps getting better and better towards metric. Okay, we are given the graphs of f equals a sine x plus q. So a is giving us ideas about the amplitude, or maximum and minimum. And we've got q, which represents a vertical shift. You know what? I don't understand. Why is this thing not pointing lately? Heban. Maybe something, maybe the update is not good. It used to point nicely as anyway, let's leave it. So we need to evaluate. Now when we've got a graph, we can determine what's going on. Remember the normal sine graph, y equals sine x. We know that the amplitude is the coefficient here, which is an invisible one. So it already tells us that our maximum is going to be at 1. And the minimum is going to be the negative version of this, which is minus 1. So the best way to talk about it is to say the maximum is equal to the amplitude, right? Or should we say the amplitude is the absolute value of the coefficient, and so will the maximum. But when we take the minimum, we say the negative absolute value of our amplitude. That is the way we can look at it. Otherwise, the coefficient of the angle itself is an invisible one. So this means our period is 360 degrees. And if we look at the sine graph, we will see that this is the sine graph. So it starts there and ends there. So that's a full cycle, 360. So that's a full sine wave. But now this sine wave is wrong because it normally starts like this instead. So it's inverted. So if it is inverted, it means our a here is less than 0. So this is minus sine x, of course. But now before we decide this is just minus 1, let's look at the amplitude. Amplitude is going to be from rest position, which is right around here. Right? Because where it starts from rest and ends at rest. So, so looking at that, we'll see that, okay, the maximum is 3, the rest is at 2. So literally that's just 1 unit. So our amplitude is 1 unit. So this is minus sine x. So we are good. It's inverted because of that negative. So please guys, be able to analyze graphs using well-known knowledge about these functions. If that is lacking, I promise you these questions will look very difficult, and yet they are very simple. But now there's a plus q. So what did we add? We can see that our graph was meant to be normally at 0, right? But now the maximum should have been at 1. But now this is at 3, which means the maximum has gone up by 2 units. So that means q is 2. Great. So that's the function of f. So this is good. So this is how I normally go about these functions, and it makes it a lot easier. But a calculation can be done for someone who is not convinced of what is going on. But sometimes a calculation may be too much to bear. All right, let's look at the cosine function. So we've got p cos whatever. Maybe let's use a different color. We've got p cos x, but cos x is just the normal cos, but it says the amplitude may be different. Normally, cos of 0 is 1, which is the maximum, but now the maximum is at 2. So it already tells us that p here is equal to 2. That's all we needed. because maximum and minimum should be at 1 and minus 1. Now it's at 2 and minus 2. So that's what this is. Otherwise, we can appreciate that this is the full cosine curve for a period of 360 degrees. So it is normal. We understand that. So we can leave that for now. And then we get to the tan function, which is g of x, which is just the normal tan function. And we see that this is all normal. And we just understand that the period here is 180, and that is a full period of the of the tan function. But of importance is that there's asymptotes at 90 and at 270. These are not indicated, so we indicate them. Okay, those are asymptotes. We need to highlight them because they are of a serious importance. Okay, or if one doesn't want to look at it that way, we can look at this as this. So a full tan period will have two asymptotes and a full wave like that. It's more like a mother function of a cubic function. There's some relations here that you will notice, but again, cubic functions you will study in grade 12. So if you understood this so well, you would start to see the resemblance, and you will start to understand sometimes why these things look alike, and you will understand why sometimes, there's differences. Okay, so that's it for the tan function. So we are good. We don't want more. So now everything is good, everything is clear, we understand where we are. Well, what we can notice is that, okay, the extra stuff here is that there's points of intersections between the graphs. That point, there's no way of knowing it without a calculation. That point, there's no way of knowing it without a calculation. But this one is very clear that it's at 360 and 2. This one, there's no way of knowing it without some calculation. Let's just highlight the ones that will need us to do more. Okay, this one is another point of intersection that we can clearly see. So this is very good. This is very easy. Now we are ready to start answering. Determine the values of A, P, and Q. Remember, the question that says determine, it's open-ended. We can do this by inspection. We can do it by calculation, by any means necessary. So 6.1, we know that A is minus 1. P is a 2. Q is a 2. Okay, we got those. By inspection, or should we say whatever means necessary. 3 marks, it means each one 1 mark. So this is where sometimes there's a bit of a leeway in terms of showing how we did our work, because it can get messy. You don't want to work too hard for just 3 marks. No. Knowing what should these graphs look like normally or under normal circumstances, then when these have been varied to some extent, we can trace exactly what changed. 6.2 says, for which values of x is h of x? Now, h of x is the graph of the cosine function less than or equal to 0. So this is happening between 90 and 270. Great. So we know that x must be less than, it's included or equal to 270 degrees, greater than or equal to 90 degrees. Because above or beyond 270 the graph is positive, below 90 the graph is positive. Okay, so normally for this notation, which we learned from paper 1, inequalities, sometimes it's termed double inequalities, so we should know how to do this notation right. Please don't find yourself reversing the signs. Okay, please don't do it. Don't write like this: 270 greater than x, greater than or equal to x, while x itself is greater than or equal to 90 degrees. Please, this is not correct. It's forbidden. We never list our integers or whatever numbers in descending order. Ever. Please. This is punishable. If you do it, you lose marks. Remember that. So 6.3. Determine for which values of x will f of x equal h of x. Okay. Now these are the points of intersections between f and h, the sine and the cosine function. So this is this point, that point, and that point. This is where these graphs are equal. At least we know those two. We can answer that easily. So we can say x is equal to 0 degrees, or x is 360 degrees, or x is... Now we have a problem with this one, because this one would say, to figure this one out is a bit of a situation for just 3 marks, and we can clearly see that this 3 marks is just whatever that would be there. But now what is it? We can guess it if we like. We can say, well, this is 45, 90, that should be 50, towards 60 or so. So maybe mid-50s, 55, 56. I don't know, guys, because ideally in grade 10 we don't do general solutions. So I get worried when I see questions like this. But let's have a look. One thing for sure is that we have the sine function, which is minus sine x plus 2 is equal to 2 cos x. Now this is not nice, because this is going to force us to try and get to compound angle identities, which is stuff that you learn in grade 12, okay? So it doesn't help us to do this at all. It doesn't. So we can say, fine, it makes sense why this tan function was introduced, because this may be suggesting that we can use the cosine and the tan function, or the sine and the tan function. But again, sine and the tan function is going to then become a disaster. So this is not really easy to handle. So the best is to try and use, because we can still see that the tan function is equal to the cosine function there. So we can just simply say, well, we know that 2 cos p, no, x, what am I saying, is equal to just 10x. This is 2 cos x is equal to sine x over cos x. Okay, right, now this is all over 1. Can cross multiply here. So this means we've got 2 cos squared x equals sine x. Right, now this is 2 into cos squared x can be 1 minus sine squared x, to try and create a quadratic. Transpose sine x equal to 0. So we end up with 2 minus 2 sine squared x minus sine x is equal to 0. And of course we put this in ascending order of the powers. So this is minus, not exponents, powers, remember. Sine squared is a power, base being sine and the index being 2. So this is minus 2 sine squared x minus sine x plus 2 equal to 0. Now, let's check the discriminant here. I don't know, guys, do you do the quadratic formula in grade 10? Because we studied the quadratic formula in grade 11. Sometimes I don't understand questions of this nature, guys. If anybody thinks about it. I don't know, guys, do you do this in grade 10? I don't remember this in grade 10. We only talked about it in grade 11 and grade 12. Of course, grade 12 being a continuation of grade 11. But anyway, things are so distorted lately. You may want to think about it that way. Okay, now what are we going to do? Let's just check the discriminant. Again, you don't know what I'm talking about if you don't do the quadratic formula, because we don't also talk of nature of roots in grade 10. No, we don't. Goodness, guys, this question is not for you then. You see, this is another issue, unless I am really missing the point. But this is another issue here that says, wow, the quality assurance is terrible, guys, and the coordination process is bad. Because why would you ask grade 10s this question? Because I don't remember this being discussed in grade 10. But what I'm saying is that I don't think this is also solvable, because I get the feeling what is under the square root sign might just turn up negative. No, it won't. It won't. Because it's minus 4ac and a is negative, so it is not. So this is probably solvable. Anyway, let's just plug this into the quadratic formula. Now, when we talk b, it's the coefficient of sine x here, which is just minus 1. Because remember, sine x is a variable on its own. It stands in for x. And that is where we're going to put it in the formula. So what we see there, we plug it there. This is if that is if you guys use this, because this is not factorizable. It's not factorizable at all. So A is the coefficient of the highest power, which is sine squared A. So that's what we're going to substitute there. And then C is the constant term. That's what we will put for that in there. Okay, so let's go for it. So we know that x here, which is the angle, is going to be, in fact, it's not the angle here. We're solving for sine of the angle. So we know that sine x is going to be minus into minus 1 plus or minus 1 squared minus 4 into minus 2 into 2. Okay, I feel like there is a crime now. I feel like I'm committing crimes which are not good. Let's write differently. Sine x is going to be minus into minus 1 plus or minus the square root of minus 1 squared minus 4 into minus 2 into 2, all divided by 2 into minus 2. Now, let's solve. Sine x is going to be, put it on the calculator, as you can see there, minus into minus 1 plus the square root minus 1 squared minus 4 into minus 2 into 2 divided by 2 into minus 2. So what do we get? We get minus 1 comma 2. To 2 decimal places, I'm going to make it 2, 8, right? Or sine x is going to be, let's change the sign there, so this is 0, 7, 8. Okay, this is sine x. So now we want to solve for sine x. As we can see, this is a point in the first quadrant, so sine is positive, so we cannot accept this one, because this is talking about when sine is negative. Sine becomes negative in the third quadrant and fourth quadrants, so we're not going to focus on those. But of course, in the fourth quadrant, it wants to give us this. So this already tells us that this point as well is not exactly on point. Oh no, wait. This is only 4 cos and tan, by the way. This is for cos and tan. So this is going to be this and that point. So these are the 2 points, that point and that point, for the tan and the cosine function. Okay, that's fine. But then this one is good enough, I think. So let's go for it and say arcsine of 0.78. So therefore here therefore we say therefore x is gonna be arcsine of 0.78. Sometimes this portion of the screen always does its own things. 0.78, it's 51.26 degrees. Okay, so this looks all right to me. So that would be the other angle, guys. I don't know how you would justify getting this angle if the quadratic formula is not indicated, because I will not show you the general solution technique, which might be a problem. So I still feel this remains a question mark. Was it necessary to ask that question? I don't think so. But here's the other thing that the examiners could have done. They could have shown us the smallest scale in each big block. What is it? Because I would suppose this would fall onto that scale, maybe something like that. So we can then read from the graph what that value is. Maybe we can say 1,2 if this is 2, or 1,1 if it is 1, depending on how the small scale would work. I suppose that should be the case. Maybe this question paper is hiding that fact, because you know what, these copies that are put on the internet are actually very different from the original, because people like to put these stupid things like these watermarks. I don't know why they put this anyway, because this is not their question paper. They didn't create it. They got it from the department. So why watermark something you don't own? Anyway, whatever. So that's the thing, guys. So I don't know if you know the quadratic formula. That's why I'm not putting it as part of my solutions. You can just guess what should this be. In fact, we can check this value for correctness. For the sine function, you saw this is minus sine. We can then put this one as 51,26. Then we add 2. It gives us 1,2. So this is almost there. So this is good. I can accept this answer. So this is why I'm saying if we were to know the smallest scale there, probably this would fall on 1,2. Then it would be easier, because we can just put the function and equate it to minus 1,2. Then solve using the usual technique, and that would work. But this one forced us down some serious simultaneous equations, which I doubt in grade 10 you get to do. I really doubt. So whatever, guys. So for me, this question is not entirely correct. It was not looked at properly by those who were supposed to. As a result, not fair. Then I would accept only 2 marks and perhaps cut the 3, because the 2 marks are valid. It's easy to see. But the third one is a little bit silly, and I don't believe this is good, unless this graph is misleading itself in terms of some modification from making the copy, and then publishing it distorted, because I would want to believe there were smaller scales here. But it doesn't look like there are any, because when we make this bigger, we should be able to see. It doesn't look like they existed at all, but I suppose that was the intention. Otherwise, without that, it's impossible to solve this point. Okay, anyway, we have demonstrated what we can do about it. Of course, what I would say, please guess a value. Okay, just guess a value there for the third one. What I would do, I would just guess a value, because when people are not serious, I also take chances. Remember, you only take an opportunity when someone lets you. So we can just easily say, for that point, we can say the other, we can just do those two, and then say the other point of intersection. We can say, okay, there's two. Then we can say the other point is such that minus sine x plus 2 is equal to 1, 2. For example, let's just assume we guessed this is 1, 2, or even if you said 1, 1. Now this is guesswork, or this is an assumption, or it's an approximation. You can just say approximation based on graph. Since there's nothing else we can do, we need to show that we're not stealing it from someone else. Then we solve the equation. So this is minus sine x equals, we transpose the 2, is going to be 1, 2 minus 2. This implies that we have sine x is equal to 1, 2 minus 2. It gives us a 0,8 minus 0,8, right? So therefore, sine x is 0,8. Say therefore x is going to be arc sine 0,8. This is quite valid for grade 10s. Arc sine 0,8. It gives us a different angle now. Yikes, but whatever, guys, because we guessed a value anyway, so we can see we needed to round off as well for the other one. We get 53,13 degrees. So this could be another way of answering. As you can see, it's going to be a range of answers somewhat. But whatever, guys, So this is also another way a student could just look at the graph, make an approximation, and then solve the equation, because the examiner here was careless, and whoever works with them, they just continued the carelessness. You know what I know people do? If there's a particular form that needs to be looked at to evaluate something, like these parameters here, you know what those guys do? When somebody submits, they'll be like, is the paper submitted? Yes. Then they'll just tick whatever needs to be ticked, and then sign and say this whole thing is proper. Send it, because they never have time. In any case, they don't know what they're doing most of the time, which is sad. People like shortcuts, and shortcuts that are not very good, a reflection on how we are as the people and as a nation at large. Can anybody take us seriously then when these things keep happening? I doubt. But hey, guys, whatever. So we get our 10 marks by force, by fire. Remember, when you're given a chance to force yourself into something, please do. Don't shy away. Don't complain without doing something. You see, I'm complaining now, but I did something, and this something is not so bad. It's not so far off. So please be in a position to look at things for what they are and do your best, irrespective of what is missing, what is not missing. Just trying to build your strength, guys, so that as you do these kind of things, or these kinds of problems and solutions, you are really, really totally independent of any mishaps by anybody else. You just showcase that, look, I'm comfortable with this subject. I'm a student and I am learning. And as a result, I'm showcasing my abilities. So don't complain like me. I have a right to complain. You don't have a right to complain because you don't know much. I do. Okay? I know much. That's why I'm complaining. Because I am hoping that somebody who sits in these meetings, bumps into this video for some reason, I don't know why, but may start to see these things and perhaps take up these points with the relevant authorities. It's not about me being right or me being pushed forward or whatever, but it's about the right thing, guys. And the right thing is not necessarily the correct thing sometimes. The right thing is what is fair to all of us, is what is best at a given moment. It may change over time, but for now, it's the best we can do. And we need to always gravitate to the best we can do at a given point in time in our lifetimes. Of course, looking for solutions at the same time so that in the future we have what can we say, undisputed. In fact, there are too many words that came to my mind. I kind of locked. Anyway, let's get to question 7. We are told that the diagram below shows a spotlight at point B, okay, which is mounted 12 meters directly above. You see this word, directly, it means it's perpendicular. So that's another way of suggesting something is perpendicular. Because when something is directly above something, it means whatever is below, that is a vertical line. So again, mathematical language needs to be something you obsess with, because if you're not obsessed with mathematical language, you will not understand it, especially when tricky questions are created using it. You will fail to see the trick. But once you obsess about it, you will almost always be on your A game, and you'll always know what the examiner had in mind. Okay, directly above point C at the front of the field. Okay, great. Now the spotlight swings 44.3 degrees from the vertical line to illuminate another point D. Okay, right. Now, which is the midpoint of AC. Okay, this is the midpoint of AC, not a problem. Of course, we can clearly see the relationship that's indicated. So sometimes problem questions can be given without an indication of any sketch. It means one needs to also be able to read and draw a sketch that illustrates the information being given. But now the sketch may choose, you may decide to take this to the other side or whatever, as long as there is a sketch which represents what is given in the best way. Good solutions are going to come. All right, so now we need to calculate the length of DC. Not a problem. So this is a right-angled triangle. So we can see that this is a right-angled triangle. So we're looking for DC. We've got an angle. We've got the side adjacent to the angle. We're looking for the side opposite the angle. So what are we supposed to do? 10. Or alternatively, someone may work out this angle using 3 angles of a triangle. 90 plus that equals 180. 180 minus these will give us that. Or even understanding that these are complementary angles, we can say this. 90 degrees minus that angle will give us that. And then we can say, okay, we want this, we can use 10 of this angle. So it doesn't really matter how we look at it, because at the end of the day, we're going to need 10 of any angle that we choose, be it that D or be it that B. So we go for the answer here, 7.1. We can say please state in triangle BCD, we know that the tangent of angle B, here you don't even need to say of angle DBC or CBD, because if we stated the triangle, in this particular triangle, there's only one B, that's 44.3. Once we state it, we don't really have to go about this in general and say this is CBD like that, We don't need to do it once we state where we are. The examiners have no choice but to understand. Okay, tangent is opposite, which is going to be DC, over adjacent, which is BC. This implies that we have the tangent of 44.3 degrees equal to DC, which is what we want, divided by 12. Of course, this is over 1. We cross multiply there. We will see that DC is going to be 12 times the tangent of 44.3 degrees. Therefore, DC is what we get. So this is nothing but a calculator work. 12 into 10, 44.3. So what matters is knowing how to use the calculator. So this is 11, remember nobody said what decimal points must we use. So all we're going to say this is 7, 1 using the general instructions. Units. Because nobody, oh, by the way, this is meters. So we're going to write meters. If you write units, you lose the last mark. Remember the trig ratio does not have units, but now 12 is not just 12 units, it's 12 meters. So this becomes meters. So again, be careful with these kinds of questions. Usually when we get to this 2D structure, there's usually some units that we need to consider in our solutions. Okay, so substitutions here and the answer are good enough. Okay. I would say maybe writing the rule in terms of this triangle is also good enough, but 2 marks would have been fine. 7.2 says calculate through how many degrees the spotlight must swing in order to illuminate point A. So basically this says we need to calculate the value of theta. So this is easy again, because this one is a bit tricky in that we have a situation where we need to look at the bigger triangle. So you see the red triangle. We know this side now. This became 11.71. But since this is the midpoint, this means that it's going to also be 11.71. So again, we know the adjacent, we know the opposite. So we're looking for that angle. So what we can do, we can just use this angle and use this triangle such that this is the opposite, this is the adjacent. Then from whatever we get, we subtract 44.3, it gives us theta. So we can say in triangle ABC. Now we know we're looking at the big one. Now what are we going to say? We will say, well, the tangent of angle B, right? Again, I stated which triangle. So B is those two angles automatically. This is equal to, the opposite side is AC divided by the adjacent side, which is BC. Right? Right. Now this implies that we've got tangent. Now this is theta plus 44.3 degrees equals AC. This is going to be 2 times 11.71, right? Right. Divided by the adjacent side, which is BC, which is 12. Right. So we know that this implies that basically theta plus 44.3 degrees is going to be the shift tan of 2. Perhaps we need a big bracket now. This is going to be 2 into 11.71 divided by 12. Okay, so this implies that theta plus 44.3 degrees is equal to, this one we can round off already. I don't know, I guess, I believe, but we can keep 3 decimal digits here to avoid inaccuracy. So arctan of 2 into 11.71 divided by 12 is 62, we can say 8, 7. I mean, to 2 decimal places is better. already. So this is good. We can say therefore theta is going to be 62,87 degrees minus 44,3 degrees. Okay. This gives us 18,57 degrees. Nice. So that is the story right there. So not a very difficult question, but again it demands a bit of thinking before you can attempt this question. So we're getting 3 marks. I guess writing the rule here is key. This is a calculation, I believe, not necessarily just general substitutions, and the final answer should be good enough. All right, okay, all right. So that's the easy 6 marks here. And we seal this question nicely. All right, let's get to Euclidean geometry, question 8. So we've got this question. So with Euclidean geometry, reasons are very, very, very key. Whatever we say, we normally are going to put reasons, because usually here everything is based on some theorems or axioms. In the diagram below, a polygon ABEFD, ABEFD, we can see, yep, it's quite strange, is drawn, okay? AD is produced to point C. Now, once a line is produced, it means we have a straight line. The idea of production means a straight line. So please be familiar with the terminologies. Produced means no angulation. It's a continuation of the same line. Okay. That lies on BC. Okay. AD is produced to point C. That lies on BC. Okay. AD. Mark and Saiva clicking blend. Or AD. Yo. Goodness, I marked the wrong line. AD is produced, so this is a straight line, okay? Let's just maintain the parallelity there. Right. That's a straight line, okay, to suggest that there's no angulation from that point D to C, from AD, okay? Now, AC is parallel to FE, so that's indicated. Given A is 3x, okay, also indicated. B is x, indicated, and ACB is 2x, indicated. But now nobody spoke about this 90 degrees, but it's here. So we need to think about it. Sometimes just throw in something and not say anything about it, so that you can struggle to figure it out. So it says determine with reasons the numerical value of x. Okay, so this is easy because we'll just focus on the first triangle. All right, we're going to focus on that first triangle. So we will say, okay, 8.1 with 8.1.1. We know that we are working in triangle ABC. We know that angle A plus angle B plus angle C, we don't need to say BCA or ACB because we stated exactly where we are. This is 180 degrees, sum of 3 angles of a triangle. So this implies that we have, angle A is 3x plus, please don't forget the caps. Otherwise, we're talking about a point without a cap. Once you remove the cap, you're just talking about a point on the Cartesian plane, so it doesn't hold water. Okay, B is x, C is 2x, equals 180 degrees. This is 4 plus 2, this is 6x is equal to 180 degrees. Therefore, x is 180 divided by 6. This is 30 degrees. Remember, it's an angle. If you're missing the degrees, you just write 30, you are dead. You lose the last mark, okay? Easy. So I suppose here you can think of substitutions, answer, but at grade 10 level, I think the reason is more important for now. So we can say, well, that is good, but this should also be a mark. But I suppose it's evident, it's clear, straightforward. So 8.1.2. What type of triangle is ABC? Give a reason for your answer. All right, okay, all right. Why do we know? Well, it's a scalene triangle. Now, I'm not very happy with this kind of a question. It's too general. It's a scalene triangle, right? We can see that because all the angles are not equal. So that's a scalene triangle. No questions about it. But of a scalene triangle, there's different types. There's obtuse angled, acute angled. What is it? If x is 30, this becomes 90 degrees. Because 3 times 30 is 90. So this is a right-angled triangle. It is a right-angled triangle since angle A is equal to 3 into 30 degrees, which is going to be equal to 90 degrees. We close shop. So this is good. So stating what it is and providing a reason, because the reason there is just to showcase that indeed we have a 90-degree angle there. So now what does this mean? Well, it therefore means that this line must be parallel to this line. How do I know? As if this is 90 degrees, angles on a straight line is going to give me 90 degrees on this side too. Now, alternate angles are equal, therefore the lines must be parallel with AD as a transversal. So there's a lot that one needs to keep in mind as they progress to solve problems here. But again, that's about what was required. Now in the diagram below, ABC is drawn such that AB is equal to BC, okay, that is indicated, and B1 is equal to B3. Now this is not indicated, so we need to show it. B1 equals B3. We need to show that. Now we need to prove that E1 is equal to D2. Okay, so this is to prove that EDB or BED or BDE is an isosceles triangle. Great. That's cute. So as you can see, guys, this is now one of those questions you would want to say it's a higher grade for grade 10s, because it's not very direct. It needs a careful thought. So what are we going to do? What are we going to do to solve this issue now? Because we have an issue. How are we going to plan our attack? Okay, this angle is equal to that. This side is equal to that. So what is it? What is it? What is it? Because now I was thinking of congruency here, but I am not quite happy. There's a lot that is missing. there is a lot that is missing. Okay, now let's look at this triangle. I think this one can help us to do this business. If we look at this big triangle ABC, if we look at that triangle, right? So if we look at that triangle, we will appreciate that essentially it's an isosceles triangle, meaning this angle is equal to that angle. That needs to come out. But when you look at D2, so what we will see is that those angles are exterior angles of these two triangles. Okay? So we will start by naming in the big triangle that A is equal to C. From then on, we describe those exterior angles. Since there's going to be this plus that, so those two should be equal. And that's how we get our solution. So we'll start by saying, well, we understand that angle A, I'm just going to jump in and say angle A is equal to angle C. These are angles opposite equal sides in triangle, or equal sides. Okay, let's just stop there for now. Then we say given AB is equal to BC in triangle ABC. So we need to be very clear why we're saying what we are saying. So this is easy. We can say though, however, we know that angle E1 is going to be equal to angle A plus angle B1. Why is that? This is the exterior angle of triangle. We name it. It's going to be ABE. Ape or abe. Habe. We can say likewise, because a similar thing. We know that angle D2 is going to be equal to angle C plus angle B1. I went some papela B3, man. Can't be B1. Okay, again, this is the exterior angle of triangle. This one is going to be CBD or BCD. Let's just say BCD. Just for the vibes. How you name a triangle is not really that important. Okay, now, do you see what we have here? We know that A is equal to C. We know that B1 is equal to B3. So what we're going to say, we will say therefore, D2 is going to be equal to A plus B1. You need to show that they are equal to the same measure. Why is that? We'll know that A is equal to C, and we saw that B1 was equal to B3 as well. We can say therefore this angle E1 is equal to angle D2. Nice and easy. Nice and easy. So we will see that each is equal to angle A plus B1 somewhat. Okay, so if that's the case, it also means that this line must be equal to that line. That creates yet another isosceles triangle, but that was not the question. But please, when solving a question, please think of what it could mean should there be more questions, because you never know in the next exam what will be interessante there. So let's get to question 9, the last one. Did I mark this one? I did not. Lord, why? I am very lazy. This is good. 1 mark. 1 mark. 1 mark. That mark. And that mark, I guess. So 1, 2, 3, 4, 5. Yeah. 5 marks in the back. However, the formal guidelines are going to showcase that I have done my job. And those are the critical steps anyway for grade 10s. Now let's get to 9. We are told in 9.1 that in the diagram below, a parallelogram. See, it's stated ABCD is drawn such that AD is parallel to BC and DC is parallel to AB. And AC and DB intersect at point O. These are the diagonals. But now we are to prove that the sides, the opposite sides of a parallelogram are equal. So as much as we know what a parallelogram is, now this is the proof. Meaning as grade 10s, you need to prove this. Okay. So, yeah. Now how do we do this? Congruency. It was not studied in grade 9 for no reason. Congruency. Now, congruency how? Well, we're going to look at this in 2 ways. First, we will look at these 2 triangles. And prove that they are congruent. Right? Right. If we look at those triangles, what is common is AC, right? And what else? We also know that this angle is equal to that angle. These are alternate angles. Is that fair? Yeah. I think izosebenza nje. I feel like it's choosing the wrong pen. Yeah, we chose the wrong pen. What? It's correct, man. It's correct. It's correct. It's correct. So if we choose this angle as well, we will see that this angle should be equal to this. Of course, it depends on how one wants to see it, guys. So do you see we've got a side and 2 angles. So angle, angle, and a side. That's enough for congruency. Once you prove that these 2 triangles are congruent, then what does it mean? It means this side can be equal to, if there's such a thing, and this side is equal to that. So can you see just 1 triangle or just 2 triangles help us, because those become the corresponding sides of congruent triangles. Ne? Yeah. Because choosing this triangle would be a lot of work. Can be done. Choosing this triangle and that triangle for congruency, that can also be looked at. Yeah. Because we've got vertically opposite angles and then alternate angles. Alternate angles. So again, we've got angle, angle. No, this one doesn't seem to work. Oh, by the way, we know something, that diagonals of a parallelogram bisect each other. And in this case, we can use this property. Okay. Right. So we can choose those triangles, or we can even choose this one and that one. So there's lots of options for a student, but knowing what to say. But I believe the red triangles or pink, whatever that color is, maroon, is the best, because it beats the 2 birds with just 1 stone. No questions asked. Okay. So let's go for it. We will say, well, 9.1. What are we given? We are given parallelogram A, B, C, D with AD parallel to BC and DC parallel to AB. Now, what is the requirement? We are required to prove that DO is equal to OB and AO is equal to OC. Wait a minute. Ndingathi ndithuze ezomqala manje. Yabona yonke lento endiyithethile. DO yo thethwa ngalento. So basically we are supposed to prove that the diagonals bisect each other. And then AO is equal to OC. Okay, all right, okay. So it looks like, guys, we don't have a choice but to use these triangles that I highlighted later. So I didn't read my statement correctly. In my mind, I thought we were just proving the sides, but here we're just proving the diagonals bisect each other. So no. So this whole analysis didn't go as planned. Okay, let's go back. See, sometimes getting ready for anything, you start to see where your mistake is. If you didn't, imagine I was going to just go all the way. Now, folks, if this is a parallelogram, we just need to appreciate something, right? We need to appreciate that the opposite sides of a parallelogram are equal. They are not just parallel, but they are equal. Because we have to use maybe half of the properties if we're trying to use the diagonals. Otherwise, we don't have a leg to stand on. So this already says, so this already highlights the fact that we're going to compare this green triangle and this red outlined one, the yellow one, and this blue outlined one. Okay, because now we need to talk about the situations. Okay, we don't need to do any constructions here. We can just run to the proof. So what are we going to say? We'll say in triangle ADO and triangle BCO. We'll start there. Great. So what are we saying in there? We know and understand that O1 is equal to O3. These are the vertically opposite angles. Vertically opposite angles are always equal. What else do we know? We know that BC, let's start by D2, whichever we choose. D2 is equal to, where did D2 come in? D1 is equal to B2, right? In the other one, what is this? These are alternate angles. You always state the parallel sides, because remember, alternate angles always exist even if lines are not parallel. For example, something like this. This angle and that angle are alternate angles, but they are not equal because the lines are not parallel. So this is why when we say alternate angles, we don't automatically mean the lines are parallel. So this is why it is a necessity to state the parallelity, because stating the parallelity simply means we are saying that's the reason they are equal. Because being alternate doesn't mean they are equal. But alternate angles where lines that are parallel are involved definitely justifies their equality. We can say also we understand that basically AD is equal to BC. What do we know? These are the opposite sides of a parallelogram. Now, we have satisfied the requirements for congruency. We can say, well, therefore, we understand that basically triangle ADO and triangle we understand that ADO is congruent to triangle BCO. Vitamin B complex. What is the reason here? We've got angle, angle, and side. Right. Yes. This is good. This is good. This is good. This is good. Now, what can we conclude? We can then conclude that indeed, what do we want? We want DO. We can conclude that DO, in fact, these two also beat the thing. We don't need the other pair. DO is equal to OB, right? And what else do we see? We see that AO must also be equal to OC. These are the corresponding sides of congruent triangles. So whenever two triangles are congruent, the corresponding sides, just do it. So we don't need the other pair. So this is it, guys. It's done, it's dusted. So please, these are very simple proofs. So you hardly need a construction here. You hardly need a construction. So let's see. How do we score this 6 marks? Well, this, that, and that. 1, 2, 3, 4, 5. Where's the 6th mark? Ooh. Angisayazi ke mina. It means one of these ones gets 2 marks. But since we used 2 things, maybe we can give 2 marks for the last one. I don't know. Whatever, folks. You will just check on the formal marking guidelines. For the perfect one, so 9.2, 9.2 says, prove, okay, first PQRS is a square. What do we know about a square? All sides are equal. Oh, the notation is going to sell us out. Okay, not a big deal, guys. A square, all sides are equal. Now, with too many notations, it becomes impossible to do it. Now, X is a midpoint of SP, okay, already indicated, and Y is the midpoint of PQ, already indicated. Now, we need to prove that triangle SPY. So, where is triangle SPY? SPY. And of course, we know that in a square, the angles are 90 degrees, right, at the corners. All right, okay, all right. We know this. Nice. So, SPY is this triangle over here. Okay, it's that angle of a triangle there. RSX. Whew. This one. All right, so those 2 triangles. Okay, all right. So this one and that one. Right. So how are they congruent? We think about it and sit back and be like, fine, sides of a square are equal. That's like that. There's a hypotenuse there. Now, what else makes them equal? Oh, by the way, we've got a side, side. Wait. It's gonna be this side, right? Can't use this side, but only that side. It's side. We've got a right angle. Yeah, we've got a right angle. But here's what is important. We know that the midpoint of this side is the same as the midpoint of this side. So we can say side angle. Because to use the right angle, hypotenuse side is going to head, but it may not necessarily head to that much extent, but other things are not clearly linked, so we cannot use them. Okay, so we're going to say 9.2.1. We know that in triangle SPY and triangle RSX, what is in there? We know that, well, we understand that SP should be equal to SR, right? These are sides of a square. Sides of a square are equal. Okay, good. 2. We know that basically S, so PY should be equal to SX, right? We know that the midpoint of each side is going to be the same, right? It's going to be the same length. Equal sides, we can say, what can we say? Yeah, doch. X and Y are midpoints. Yeah, you can just say X and Y are midpoints of equal sides. PQ and SP. I would put it that way, so that they should be equal, because if they're of equal length, they will have the same midpoints, or should we say the distance from one vertex to the midpoint. So we also know that basically angle P is equal to angle S. This time we may want to say it XSR or RSX. Maybe let's put it that way. RSX equal to 90 degrees. These are the corner angles or inside angles of a square. Maybe we don't use English too much. We use interior angles. Hi man, hey, didn't want to palagag bingo. Interior angles of a square are always 90 degrees. Now from here we can say, therefore, triangle SPY is congruent to triangle RSX. The reason is side angle side. Okay, good. 2 sides and an included angle. It's another condition for congruency. Is done, is dusted. So of course, guys, 1, 2, 3, 4. So 6 marks, it means something else gets 2 marks. Perhaps the statement and reason deserves 2 marks. And perhaps the statement as well and reason deserves 2 marks. I believe that's how we score those 6 marks. Not a very difficult question otherwise. 9.2.2. We are told that R1 is X. identify with reasons another angle equal to x. Just one. Okay. So obviously this one should be x as well, isn't it? Those are the corresponding angles of congruent triangles. No worries about it. So we know that, well, S1 is equal to angle R1 equal to x. These are the corresponding angles of congruent triangles. So statement, or maybe identifying the angle and the reason, gives us 2 marks. 9.2.3. Sivale lezo. Prove that SY is perpendicular to RX. Oh Lord, 5 marks. That's a killer question. Okay, how are we going to do this? What will inform our actions there? Okay, let's sit back and think about it. Again, we should probably be looking at congruency. Yeah? We should be looking at congruency, I'm thinking. But all I know is that if this angle is x, this angle right here should be 90 degrees minus x from 3 angles of a triangle. But seeing that that angle is x as well, so it would mean when I calculate here angle O1, I'm going to get 90 degrees. And if I get 90 degrees, I am done. So that's about the business. So what helps us to solve our matters here is this small triangle. So we can go there and say in triangle SOX, SOX. What can we say there? We know that angle x1, right? We need to show this calculation x1, plus angle S1 plus angle S2 plus angle R1, we should get 180 degrees. We just want to go about it nicely. Sum of 3 angles of triangle RSX. So you see, we're using another triangle to get into another triangle. Now this implies that angle x1 plus this is 90 degrees plus x is equal to 180 degrees. Therefore, angle x1 is going to be equal to 90 degrees minus x. We needed to do that. So can you see, we're using another triangle to understand another triangle. And mind you, we have already proven that S1 itself is actually x, right? So we can say, well, we will say then, we know that basically angle x1 plus angle S1 plus angle O1 should get 180 degrees, sum of 3 angles of triangle. Since we spoke about another triangle, we need to perhaps say that we're back onto the next one, on the topic. But the topic usually, if we don't say something else, it means we are relating everything to it. This implies x1 is 90 degrees minus x plus, S1 we saw above, this is x plus O1 is equal to 180 degrees. This implies that Kutheni ingathi sekukhona lezinto nje i-right yonke lento because this guy takes care of that guy. Therefore, angle O1 is going to be equal to 180 minus 90 is 90 degrees. Therefore, we can make a conclusion SY is perpendicular to RX. We are done. Yeah, it's a not so obvious question. So again, dealing with these kinds of questions many times makes you very easy and comfortable when seeing them. But if you're not comfortable, you become miserable and you cry. In my opinion, guys, whenever you write a paper that has Euclidean geometry, start with Euclidean geometry. Especially if you're not strong in Euclidean geometry. When your mind is fresh, you will score points, big marks. Even if you don't really get 100% of the question, you will definitely get above 60%. When your brain is not distracted, not disappointed by the topics you like, asking questions that you cannot attempt or that are impossible, you will smile. Because you cannot do Euclidean geometry in a hurry. That's the problem. You will never win. Euclidean geometry is one of those guys who are like the ladies, you know. The ladies want your time. Even when you look at it, it's just being spent. Nothing constructive is being done. They just want you to come and sit and look them in the eyes and lie to them. And then they cry later and say, yeah, this men are liars. Yeah, dog. Because what do you do really when you sit with them? Nothing. Anyhow, that's the thing. So Euclidean geometry is like those attached. Is it attached or very, I don't know, how do you describe them? Girlfriends. But you are grade 10s, man. You should not be doing anything like that. Why am I talking to you like that? But yeah, anyway, you guys are already doing crazy things anyway at this age. Whatever, what can we do? Just have to face it. So that's the one, guys. That's the one. Let me just impress you a little bit, my grade 10s, but this is now off topic. Since I spoke about Euclidean geometry wanting time, there's something related to time. What did I say? Women like time. So women, I want to prove that women, I'm just going to say women. You are not women. You are kids. Women are evil. They are dangerous, these ones. They incite men into violence, man. Men don't fight when they are alone, even if they talk nonsense to each other. They never really fight, you know. They don't. But bring women into, every man wants to now defend their dignity or whatever. They fight with even friends, bitterly. But if you would cancel women from the equation, men would not do anything. Men go and steal to come and impress women. So women are evil, eh? Not you. You are children. But I'm just trying to show you something. Of course, guys, don't read too much into this. It's not that deep. I'm just being silly right now. And just to show you a mathematical way of doing things, you know, so that you can even think of things no one has thought of. And use your mathematical skills to go around business. How do we prove? We know that women like time. So we can just say time. Because women, if you don't spend time with them, you are in trouble, right? But they don't just want time from you as a man. They also want money, Baba. They want money. So women are both time and money. Requirers or spenders. They like these things. But now there's a saying that says, well, we know that money is basically the root of all evil, right? The square root of all evil. Right. So, but what do we know about money as well? We know something about money. That money, we say time is money, isn't it? So we normally say time is money, or money is equal to time. All right. But now here's what is important. We need to think about this, that, okay, our lovely women, so this implies that, oh, by the way, there's two things, and say, okay, we know that money is the root of all evil. At the same time, we know that basically money, or you can say also, time is money, right? Time is money. So this implies that our lovely, beautiful creatures are basically equal to, now if you say time is money, this is now money squared. They are basically money times money. This equals money squared, right? But now what is money? It's the root of all evil. So money is basically the root of evil, but then we square. Once you square, the square goes away. It proves that these dudes are indeed evil. Don't do this. Yay. But guys, we need to be careful. Women are very, very, very dangerous. Even maths proves it. It's not me, it's the maths, guys. So we know that women like time and money. So they're just time times money. But we know that money is the root of evil as well as time is money. Okay? But maybe let's reorganize our proof a bit. It doesn't look coherent. It looks jumpy. Come out. Come up. Right? Right. And then, what are we going to say? From that, we will say now here, our women are going to be money squared. Okay, so something just decided to remain behind. Okay. So, this is the story now. This proof is now following in nice order. This is money squared. Okay? And we'll say this is an implication. And this implication, we are literally substituting. Okay? Yeah. And the proof is done. So basically, we wanted to prove, are really women evil? Well, let's find out. Women require time and money from their partners or their significant others. But we know that time is money. So this means we replace time with money. So women are money times money, which is money squared. And they want more money anyway. Now, there's also a saying that money is the root of all evil, right? So when you substitute there, the square root goes, and guess what? Anyway, guys, that's meant to make you laugh rather than to read too much into it. But you know the reality around us. I will not go into it because that would sound biased, and perhaps what do these women say nowadays when you say negative things about women? They are so sensitive and petty. Yeah, a modern woman, something else, man. But hey, leave them alone. Social media is destroying their minds. That's all I can say. And also, entertainment industry is just planting fantasies into our women. Now they just want to live in a bubble of some kind. I don't understand where they get these ideas. They watch movies and read rubbish magazines that actually push them into believing in certain ridiculous things that no normal woman would actually imagine if not influenced. And as a result, they are so fragile, man. You cannot even trust them with anything significant. You cannot trust them with your life. Right. But what about men? Men are also very dangerous. Those are the lions of the jungle, men. They don't care. They are very ruthless. They are not empathetic. Again, why? Because of social media. Men, the day they decided to seek validation from the rest of the country, even people they don't know, they have become a disaster. Because men never really cared what people they don't know have to say about them. They only cared about those who are in their circles because they understand their very beginning and progress and disasters. So in a way, they become controlled. Again, we have broken that social fabric that keeps us together by trying to be as individualistic and consequentialists at best. And as a result, society has broken down. Now, who can you trust? Nobody. Yep, women were the actual breaks in how dangerous a man can be. Because I grew up seeing men who were very impossible in society, but the moment they married, you would see a father and a respectable man in society. They change 100%. Even in my family, one person I know in particular changed the day he married. Otherwise, before then, he was called a strong man. Everyone called him strong man. When he's about to come home, we would be told, we are the strong man. So, all I'm trying to say, how women have turned into the evil type of women because they are so dangerous. They start wars they cannot finish. They end up becoming victims of fights they should never have engaged in because they are of weaker strength. No matter what they think, what they say, no matter how we can politicize how we should protect them, the more we talk about it, the more it goes wrong because you're already inciting the other gender to be sentimental about everything. Just a small little squabble results in a death because now people are angry. They're not happy. They will abuse their strength, their natural strength, because they live in this nonsense world of social media and all the rubbish. You find men gossiping in social media. They, fighting and insulting each other on social media. I'm like, why would you insult someone you don't know? And do you even know what those people are capable of? You don't. So even if you are joking, how do you joke with insults with someone you don't know and understand? Because you didn't grow up with that person. You don't know how they are when they are angry. But the people you grew up with, you grew up fighting with, you know very well what to not say to them. You know exactly what to not do to them. And you know exactly what to do to them because you know what you would expect. Now people are getting shot left, right, and center. They're getting stabbed. A lot of things are happening because people live, with influences far away from where they grew up. They actually disregard how they were raised and start adopting ideas that have no basis in their lives, that will never help them anyway. They listen to people who are also failures in their own lives. But because they are so much in denial, they will go out there in the world and preach rubbish because they just want something to feel good about. Why would you even want to feel good about saying something and people applaud you? Didn't you get enough love from your parents so that you can be confident you matter? Why then do you care what the world around you have to say? Of course, not to say 100% not care, because if people talk, especially negatively about your actions, it means there's something wrong definitely about you. It's never really hate that can make people say such things. But there are some misconceptions, though, that spread wider than that, which is wrong that a person does. But I suppose you wouldn't really totally live your life seeking validation from those who did not raise you, those who didn't grow up with, in a community that you did not perhaps grow up in. I mean, what are you? What are you if you're like that? And this is the people of today. Anyway, guys, That was just a rant. Take it as such, with a pinch of salt, of course, because there's lots of truth in it and there's a lot of intent in it. But of course, I'm not going to be very hardcore. You will not understand. You will actually start crying and crumbling, and that's not my intention. My intention are to challenge your ideas in your mind and what you believe in, at the same time to enhance your ability to self-introspect and to see exactly what is around us for what it is than what it is given to you as. All right, please face reality as best as you can. Forget fantasies. Yes, in part, you may reach some, but remember there's no such a thing called a soft life. Nobody lives a soft life in this world, ever. A billionaire doesn't sleep very well like you do, because he has partners that he shares his billions with. And when those people want their money, they want it now. And a lot of trouble can happen if that money is not brought. So those people are not at all at ease. Yes, they may have a boat, they may have a private jet, but remember that private jet has a pilot that needs a salary. That private jet needs a technician that will check it and make sure it's well. Engineers actually make sure everything is working well. So trust me, it's not about just owning a jet. It's a huge expense by itself, because there's lots of people you need to pay for that to be well. And when they fail, which is what happens, and guess what? When that happens, you are in serious trouble. So you have to always think of a backup plan. What am I going to do when this fails? So the responsibilities are just too much, guys. So when they start to showcase themselves living large, if you want to believe that that's living large, owning a mansion in some places, many places, that's just them trying to show you the pressure they live under. And now they're just trying to project these nice things to try and make themselves feel good. But they actually don't feel so good. Okay, of course not all of them, but many don't. If they did feel good, they would not be looking to loot money from governments all around the world while they are filthy rich. It just tells you those riches don't exist. They're on paper. The actual riches that they have is nothing close to what you see them having. In fact, most of what they have is in debt. They are actually in debt than they actually have the money that you all believe they do. Of course, there are some exceptions to what I'm saying. Not everyone operates the same way. But if you're in a corporation, I promise you, you are likely to be in some huge debt than you would be technically free of debt. That I can promise you. But if you are perhaps alone in what you do and you really make good money, then you stand a chance of being debt free. But even then, you're not going to have all these things that people try to portray. So now you guys watch movies, you see someone owning a flight and you're just making a call, fuel my jet, I'm going to go. It doesn't work like that, folks. It doesn't work like that. Everything has to be scheduled, because the one who's flying your plane is not you. And you need to consider their time that they're going to be with you. That's money for them. Now, do you have that? So think about it, guys. Everything that you will ever have in this world, you will work for it. Even a simple life, you still work for it. Okay? But the nice thing about a simple life is that you don't have to always worry about, other issues than just your next meal, your next clothes, your next destination to visit or to travel to, and, the bills, school, health, household bills and stuff, transportation, and those are easy to handle. They don't really make you not sleep at night. And if you're comfortable in those, then you actually live the best quality of life. And you will notice you will live longer. But if you're living under stress, there will be heart disease, there's going to be this, surgeries, because even your eating habits are not going to be so good. As much as it looks as if it's good, it's actually not as good. There's nothing that beats home cooked foods. Because all these other foods you eat at restaurants, hotels, and what, they look nice, but they're not the same way as the food you would eat at home in terms of their nutritional value. So don't fantasize over rubbish things and end up living a life that is miserable, that's going to lead to your early death. Remember, don't challenge things you cannot determine or predict their behavior. Women of today like to challenge creatures that they didn't grow up around, creatures that come from lands that they cannot even locate, and they want to challenge them just because there's this narrative out there that if I'm right, I'm right. Be very careful of being right if you don't know how to control that status, by the way. You need to pick your battles very well. Euclidean geometry is one such a danger. Actually, guys, all the rant is all about Euclidean geometry, but I don't know why I had to go away like this, but I did anyway. And you can deal with it if you have a problem. Well, the video has ended anyway in terms of the education. Now it's just me talking. All I'm trying to say, guys, choose your battles. Look at the questions. The best ones, though, because this contributes a lot of marks, as you can see. You see, look at question 9, 19 marks plus 9. See, so that's quite a lot of marks, eh? That's quite a lot of marks. Almost 30 marks, you see. So this is something that you can lose if you come to this at the end, because you will be out of time, you will be tired. So you cannot do Euclidean geometry as the last section in your paper, ever. If you do that, you're just applying for suicide. Trigonometry depends on the questions, honestly speaking, and the level of the question, and that changes all the time. So you can do Euclidean geometry, you can do trigonometry relatively under a bit of pressure. Most of the questions are straightforward. Analytical geometry can be handled under pressure and stress. Statistics can. So for me, if I was to write this paper, or this paper was me writing it, I would start here. Question 8, take my time, to question 9. And pick my battles, of course. I'm not going to answer questions I cannot figure out. I answer those that I can, but while my brain is still fresh, so that everything is perfect. Then leave the ones I cannot handle immediately. Go to the next section. Again, even there, I look at the areas that I feel I'm not so confident. I start there. Chow those questions. If functions are the problem, I start there and see how well I'm doing. Sometimes, as you do well in a section that you don't trust yourself in, you start to feel enthusiastic and your brain starts to go into the easy cruising mode. You start to relax. The anxiety goes. Because you know all that is left is sections I'm confident in. Now there I can, really make up time. At the same time, don't take those too lightly. Make sure you check your answers as you move along. I promise you, this will never be a problem ever again. When you're writing maths, you will expect it with an anxious enthusiasm, I would put it that way. Or an enthusiastic anxiety. Not a miserable anxiety. Anyway, guys, goodbye. I'll see you next time. Keep well.